Sir,
Hi, yes.
may I quickly ask you a question about the sun, please?
Yeah, go ahead.
With task one, am I just supposed to make it look like the sample output?
Yeah, so the sample output gives you certain things, uh, does some printing for you. All you need to do is implement the class with the attributes and then implement the methods that the class needs.
Because I did everything that I followed step by step.
Yeah,
Like I made use of your set get method and stuff like that, and I'm getting values from your run assignment. And I see what you mean by comment everything out and comment it out one by one as you implement the code.
yeah.
So so far I'm saying I got the output that you asked me to get in the sample output, but I didn't need to make use of the distance formula
How do you mean?
because it asked me to print it prints the
Mm-hmm.
registration, and then it asked me to print the current position.
Mm-hmm.
But then I don't know what you mean by I don't know if maybe that's what you meant. But for my current position, I just printed it out as is, like I typed it out as a string, and then I printed out the altitude and the latitude and the longitude as seen on the example, and looks exactly like that.
Okay. Are you using the run assignment?
Yes, but
Okay.
my code is opened up, and the run assignment code is opened up next to it.
Okay.
So it's taking the values from your run assignment.
Um, so let me see if I
You'd like me
understand.
to send you a picture? Could you just
Yeah, you can, or you can share your screen.
so send me a picture. I can't share my screen because I'm using my tablet, not my
Okay.
computer.
Yeah, go ahead. You can send a picture.
I'll say okay. So I'll show you now because so so it's okay, and then oop,
All right, let me have a look. Print, oh, for print info.
yeah.
Yeah, that's fine.
Let's see. But I it's online
Yeah.
on WhatsApp.
Oh, yeah. I looked at it now.
Like so I can see in the first picture that they have made all the code properly,
Yeah.
which references to your run assignment. Like I think you can see on top there, your run assignment job is next to it.
Mm-hmm.
And then on the second picture, you can see that I'm not printing it out as a string. I'm printing out the actual values from the run assignment, and it looks exactly like the sample output.
Yeah, that's fine.
So is that basically my task one complete?
Yeah, that's print info method complete. Yeah.
But I didn't make use of the distance routine.
That's fine. That'll come in when we, so with run assignment, if you then create another vehicle, then you can call the distance to on it. And
Uh, so that will that be for task two maybe?
it's still part of task one, but the run assignment will do that for you. So if you look, let's actually pull up the run assignment. Let me have a look. I think it's
No, but sir, if you look at my code, I didn't add the distance code yet because I saw that my
Oh,
output looked
no, you'll still need to add the distance code. And then task one is done.
no, but sir, what's the point of me adding it if I already get the same output?
It's not about the output. It's about having the correct
Yeah.
interface to your class.
Okay.
Yeah. So we're asking you to design classes now, not just programs that give output.
Okay, I think I see. So,
So when we
this distance for
yeah?
yeah.
No, go ahead.
I was, I was I'm looking at this formula and it's saying A and B. So clearly it's a distance formula between two vehicles, right?
Yeah.
So, okay, I'm looking at your run assignment. Is the second vehicle the
It's
the
vehicle COS and it's got a
yeah,
registration
and vehicle one
ZU-COS.
and then vehicle CS1.
Yes. And then you say vehicle CS1
Oh,
dot distance to vehicle COS.
okay, but so I must just do the distance formula between those two, but I mustn't print it out in the output.
No, so you need to write a method that will
Yeah,
take a method in the class basic vehicle that will take
yeah,
another basic vehicle parameter or argument
yeah.
and then calculate the distance between them, and you return the distance between them.
Yeah, no, so I'm
Yeah.
saying that you want me to calculate the distance between them, but you don't want me to display it on the screen because on a sample output it doesn't show the distance between the two vehicles.
No.
It just shows the information
Yes.
of the first vehicle.
Because run assignment on line 23 of run assignment, it does that. So it
Yeah.
says the distance between vehicles and then it calls that method.
It goes in the print info already.
Yes. Yes.
But doesn't that still mean I must place it in my code to print it out in a terminal?
No, no. So with classes, this is the whole idea of
Oh,
classes. We have an
sorry,
interface.
suppose I
Yeah.
think yeah.
Yeah, go ahead.
So now to say, so now how come in your sample output on your assignment it's
Mm-hmm.
not giving us the distance code in the output? Not the code, the distance, the distance number.
Let me have a look.
Like it's just asking us information of the first vehicle and not asking us to print out the output for the distance between the two vehicles. So you understand what I'm saying?
I'm not sure I understand. So let me open it up here. Assignment 2
Okay.
in the sample output. Distance
Yeah.
between vehicles over here.
Where does it say distance between vehicle?
Over here in under task 2.
Oh, so
Yeah.
under task 2, we're gonna have to show the distance between the two vehicles.
Yes. So remember, we're marking you on the specification. So if you've implemented everything that the object needs to have implemented. And part of that is that we need a method.
Wait, that's what I asked basically. So I
Yeah.
asked previously isn't my task 1 essentially complete because my output looks the same like the sample output? So only for task 2, that's where it's asking you to display the distance between them.
Yes, but I feel like you're getting confused about the what it means to complete the assignment.
Okay.
Completing the assignment is not that you get the correct output. We're not measuring your output.
Yeah.
We're marking the actual class that you've written. So we're marking if you have all the methods, if you have all the attributes we asked for, and so on. Does that make sense?
Yeah.
Yeah.
Okay.
So,
Okay. Yes.
so the run assignment is just to help you test your code.
Yes.
And then you can check if you've completed everything, you can check if your output is the same as the sample output.
Yes.
But it
Yes.
won't, the goal is not, do you know what I'm saying? That we're not marking your
Yeah.
output.
You're
Yeah,
marking us on our. It's like math. You're marking us on our methodology, not really our final answer.
exactly. Yeah. So the whole idea is that if we give you a specification for a class, you can implement it.
Okay. I
Yeah.
think I see what you're saying, sir.
Because
Sorry for taking up.
no, it's all right. We'll get started with the lecture just now. But I think it's
Yes.
important for everyone to realize that right. We'll get. It's important for everyone to realize that when we write object-oriented programs, we are not always looking for just the correct output or the printed output, because these objects
Yes.
might interact with each other. So we need to make sure that
Yes.
the interface of the object is correct.
Yes, sir.
Yeah. So that's kind of the thinking that you should have when you approach the assignments.
Yes, sir.
Okay. Excellent. So if there are no further questions about the assignment, we're going to cover today everything you need to finish task 2. So that is the concept of inheritance. We'll talk about inheritance. It's not a very long lecture. I'm also going to look at how we compile these programs and just maybe do a demo. So it's fine that you ask questions about the assignment. We'll have hopefully lots of time at the end of the lecture to ask and answer more questions and maybe do a bit more practical coding.
Yes, sir.
I'm thinking on Fridays we'll have the consultation session, but we'll also do some practical examples. We'll maybe go through the
Yes.
code that we covered in the lectures.
Yeah, I was gonna say Friday can also go over the like code examples of the
Yeah.
lectures in the week that Sir couldn't like go over.
Exactly. Yeah. So I think we'll shift it to that. I'll probably also shorten the lecture content so that we can maybe have demos at the end of a lecture.
Yes. So
Okay.
yeah, and obviously tomorrow we're not gonna be seeing so it's
Yes.
like still okay, cool.
No
Good,
lecture
good, good, sir.
tomorrow. Yeah.
Yes.
No lecture tomorrow. Then 2 kind of content lectures, Wednesday and Thursday, and then Friday is obviously the demo and question and answers.
Yes, sir.
All right. So if everyone's on board, we're going to head on through with inheritance. Like I said today, we're going to look at the compilation process a little bit. I touched on this last week when we talked about what the main method means. And then we're going to look at the basics of inheritance. Inheritance is where object-oriented programming kind of really gets quite powerful. The first benefit of object-oriented programming is that we can think in terms of concepts as opposed to just data structures. So we can think the concept of a vehicle, the concept of a person, the concept of what a job is or what a product is. It's easier for us to think in terms of concepts. Inheritance is just kind of leveraging that benefit and making it a bit more effective. So, but first we'll talk about compiling a bit. By now, I hope you are well familiar with compiling Java programs. Just a reminder that Java programs are compiled into Java bytecode, which is then run on a thing called a Java virtual machine. What a Java virtual machine is just like a fancy program that can translate the Java bytecode into system instructions, right? So, with object-oriented programming, you can compile a class on its own. So if you're writing a lot of different classes, it might be useful to check if your syntax is correct by trying to compile just one at a time. And in this way, you don't get thrown a whole bunch of errors or showered with errors, and you can kind of narrow it down. Okay. So every class in Java that has a .java source code file, and every class definition. So in your file, you can actually have multiple class definitions Don't worry about it too much. That's called inner classes or I think nested classes. We'll look at that a bit later. But for every class definition, so when you have public class, in a .java file, the Java compiler can produce a .class file. And that .class file is usually in Java bytecode. When we bundle a whole bunch of class files together with one class that has a main method, we can create a jar file. And a jar file is like a portable executable Java file. So the game Minecraft was originally just distributed as a .jar file. And a lot of it is written in just Java, although I think it's changed a bit now when Microsoft acquired it or something like that. I think you have a Java edition and a Bedrock or something like that. But that's beside the point. So we can compile any class, but like we said last week, only if the class has that special main method, the public static void main, with the arguments, so that specific method signature, which is made up of the type, the name, and the number of parameters, as well as the method name. If we have one of those, then we can run that class. Okay, so that main method is called the entry point. So I have a couple of files here, main.java, that uses a file called hello.java, and we'll look at that quick. So I'll close this, and I'll go here. So let me just make this a bit bigger. We have the following classes, main.java. These are for later, but main.java and hello.java. If we look at main.java, we can see here that it has our entry point method, public static void main string, well, string array arguments, and it uses a class called hello. And if we look at hello, right, hello is a public class hello, and it has a single, what method is this? Any guesses? Or it's a special method, but what is this type of method called?
A constructor.
Exactly, thank you very much. It has a constructor that will print something when the hello object is created. Okay. So what we can do, you'll notice there's no main method here. We can say Java compile or the Java compiler and give it not hello, but hello, and it will compile the class. But we are not allowed to run the hello class. So if we tried that, we will get an error, main method not found. And it gives us, please define a main method as, and it gives the method signature. Okay. However, if we look at the main.java, we use hello world, and then we can compile it, main.java, and now we can run main.java, and you can see that it is actually using it's calling the constructor, and the constructor is printing something out, so we said created hello object. Okay, so something you should know is that if we now look at our directory, we have the two class files. Okay, so if we remove the two class files, right, we no longer have the class files in the directory. And if I compile the hello class, I now have a hello.class file, but I have no main.class file. However, if I remove hello.class, and now if I compile the main class, which uses the hello class, we'll see something. So if I now say to list everything, you'll see that it has noticed, the compiler has noticed that the main class, let me just go back. Sorry, just give me a second. The main class uses the hello class, and so it has compiled, it looked for and compiled that class as well. Okay, so whatever the main, the entry point, so the main method, whatever class contains the main method, the Java compiler will go ahead and look for all the different classes that it's using and try to compile those as well. And if we move the hello class, so hello.java outside, and then remove all the class files and try to compile the main class, we'll say, oh, the Java compiler cannot find our class file because it's no longer in the current directory that we're looking in. Okay. If we then put our hello.java back, we put it back, it will compile correctly. Let me just have a look. Oh, never mind. I've messed this up somehow. Let's do this. And that. Okay. Okay. So if I now compile, it compiles fine because it can find the hello.java file. Okay. So whenever you're in a Java class and you go import whatever, java.util.scanner, I think. Yes.
I'm a bit confused.
Mm-hmm.
Is it just making a class saying hello?
Yes. Yeah. So we're just creating an object that says hello, and that is this class over here. So we've defined this class here, hello.java.
Okay.
Yeah. So this is just to show you how compiling works with object-oriented programming.
Doing a normal. It looks like you're doing something from last week with the OOP.
Yes. Yeah. So this is object-oriented programming with Java and how the compiling works. So when you compile the program, you know, this is what's happening. And these are kind of the rules. So when you import a java.util.scanner, these class files are already compiled for you. And they're sitting somewhere in your computer, installed somewhere in your computer. Okay. So when you say import with some sort of package name, the Java compiler will go and look in that place. Okay. So we'll cover this a little bit later in the term, but for now, let's return to compiling everything. Okay. So you can see here that only the main.java contains the main method. That's our entry point, and we can only run classes, like run them directly, when they have a main method of that special method signature. So we can compile every file separately. This is useful for checking for errors while we're in case we have a big project with lots of classes. However, if we try to run a class that has no main method, we get an error. And the Java compiler is helpful. This is why I encourage you to mess things up and read what the compiler tells you. The Java compiler is very helpful and tells us that there's no main method in the hello class. All right. So if we compile the main.java class that we defined, the Java compiler sees that it's got that special main method and takes note and says, okay, I need to find where this is because that's going to be my entry point. Then it looks for any other classes used in the file. It'll compile those if they are local classes or classes that you have specified, or if they're part of the Java library, it'll go look them up in your system, in your computer's installed libraries or system files. Then it produces a .class file, not only for the main Java class, but also for any other class that you've coded that is being used. Okay, so the compiler is quite smart. It won't just compile everything in a directory. It'll try to find only the classes that are being used. And then, like we said, the main method is the entry point. You can think of it like the front door to your program. Okay, that's where the Java virtual machine knows to start executing. This is not very different to something like operating systems like Windows or OS X or Linux. They all have an entry point or a main method that gets hooked by something called the bootloader. So when you boot your computer and you're ready to start your operating system, the bootloader knows exactly where that entry point or that main function, startup function is. Okay, it's the same thing for our Java classes. Okay, so a class without a main method, right, the correct signature, does not have an entry point. And I actually encourage you to go and try and write go and overload the main method to not include parameters or to have extra parameters, and then see if you can compile and run it directly. So comment out the normal main method. Okay, so is everyone okay with compiling Java programs, and especially compiling object-oriented Java programs? Let me just double check if we have anything in the chat. Okay, so I'll answer the question about the zip files. Answer the questions about the zip files at the end. But as long as everyone else is on board, we can continue to the concept of inheritance. So we're now working not just thinking about data, but we're thinking in terms of objects. And these objects represent things we are familiar with: people, jobs, products, websites, servers, computers, whatever. However, now we're going to learn about something called inheritance, which is another concept in the object-oriented programming paradigm. So we have this idea that cats and dogs that's the classic example. Cats and dogs are not alike, right? They fight, or they're enemies or whatever, but they're both animals. In the same way, classes can kind of have common attributes and behaviors. If you think about cats and dogs, they both have fur, or at least most of them do. They both can make a sound. They have 2 eyes, 2 ears. They can hear things. They have 4 legs. They have tails, right? There's a lot of common behaviors. So if we try to code something about cats and dogs, we would want to save ourselves some of the work. Instead of having to code everything for a cat and then code everything for a dog, we can maybe have an idea of an animal, and then a cat and a dog are like special versions of the animal object. Okay, so classes are a lot in the same way, and when we think about inheritance, we want to think about going from a very general class, kind of a general concept, and making more specialized versions of that general class. So what do we mean by specialized versions? The same thing with the idea of computers. You have an idea of a computer where you have maybe a screen, you have a hard drive or some storage, some RAM, right? All these things. But then you have something like a desktop and a laptop and a phone. And each one is slightly different and special in a certain way. Like a phone has maybe lacks a keyboard or a physical keyboard, but is able to use the mobile network. So like a Vodacom network or something. Whereas the laptop has a battery instead of a power source. It also has a keyboard, right? So inheritance allows us to derive or extend a more general class into specialized classes. Okay. Then when we inherit, we get all of the attributes and behaviors of the parent, or the superclass, as we say, to the derived class. Okay, so I've put it in bold there. Inheritance is the idea where we can make special classes from a more general one, and we call those specialized classes derived classes or child classes. Okay. The more specific term is a derived class. Is everyone with me about what the concept of inheritance is?
I'm gonna lie, I need a bit of an example, please.
Okay, so that's exactly what we'll do now. Let's have a look at a person versus a student. Okay. contrary to popular belief of some lecturers, students are actually people. They're human. But with a person, we have a name that a person has, and they might have a get method and a set method, get name, set name. Okay, so every person in this course, myself included, has hopefully a name. However, we make a distinction between you as the student and myself as the lecturer. So if you think of Canva, I have special abilities on the Canva page where I can add content and edit, edit the lecture slides or whatever. And you as a student have a slightly more limited number of actions. However, you can also do things I can't, such as take tests or submit assignments or whatever. So what might be happening behind the scenes is that Canva has the idea of a person or a user class, and then it is inheriting from that general user class and creating more special roles. So a student class and a lecturer class. Okay, does that make sense?
So say one
Yes.
more time, please.
Okay, so if we think about inheritance, we would have the idea of a person, which is a more general idea. And then we have the idea. Yeah?
Sorry. So you say like a person is something general, the student is something more specific.
Exactly. So if you look at the diagram here, a student, so this arrow here pointing back to the person means that the student is a more specialized version of the person. So it inherits from the person. And what makes a student special is that a student has a student number. Does that make sense?
So basically you're saying a person is anyone, but you get multiple students with multiple student numbers, which makes them all unique.
Yes.
Like that.
And it also means that a student is a type of person.
Yes.
Yeah. So you can have multiple people, but not everyone is a student. You can have multiple students, and they're all persons.
Wait, what did you just say now, sir?
So we can
What was the
have,
last thing?
yeah, so we can have multiple persons, but if they don't have a student number, they're not students. So you can have multiple persons, but not all of them are students. You can have multiple students, and all of them are a person.
Yeah. Oh, yeah. So basically, not every person will be a student. They can just be, for example, a chef, for
Yes.
example. But every chef and student will be a person.
Exactly. So that what you just touched on there is the concept of polymorphism. We're going to look at it later on. But for now, just knowing that you can inherit things from a more general class is the core idea. Okay.
Yes, sir.
And if you recall, in Java, a class is a type. Okay.
Yeah.
So that's the key thing we should be learning today. So let's look at some code. We're also going to dive into the demos. We might implement something like this. So given this UML diagram, right? And this arrow in UML indicates inheritance. Given this UML diagram, we can see we have an attribute for a string called a name. And then we have a constructor for a person. We have a get name and a set name. So a getter and a setter, presumably for the name attribute. All right. Then for our class student, it inherits from the person, and it has another attribute in addition to all the person's attributes. It has a student number attribute, which is a string. And then in addition to all of the methods that a person has, it has a constructor for a student. All right. So now, in a file called person.java, we will define the person class. So public class person has a private attribute for a name that is of type string. It has a constructor and it sets the name to no name yet, we can overload this constructor to take a parameter and set the name, or set the attribute. We are also using the this keyword. So remember, the this keyword means to refers to the current object, and it's used to resolve ambiguity. We have our get method that returns a string, and it just returns this.name, and it's called getName. It takes no parameters. We have a public void setName. SetName has one parameter called name, and here we're using the this keyword to say that the current object's name is equal to the parameter name. And then finally, we've added another method called public void say hello. And in say hello, we say, hi, my name is the name of the object, or the name of the person. Sorry. So when we're talking about the class, this is the blueprint. When we create a interactive version of the class, it's called an object, right? An instance of the class. Now, in a separate file called student.java, we are going to create the student class, which extends the person class. Okay, so this right here is the keyword right here. This is the keyword we should be looking at when we're doing inheritance. Right, so when we say extends in Java, we are saying, hey, we would like to build off of the more general class that we've put there. So in student.java, we have the class student has now an additional attribute called a private string student number. You will notice that we do not add the attributes of the person class again, because we are extending the person class. And we have a new constructor with this weird function over here, right? This weird function called super. If you're doing task 2 of the assignment, you should maybe pay attention to what this function does. I'll describe it in just a second, and we're setting the student number to none. We can then overload this constructor to take a parameter and set the student number. You might ask yourself, how do we set the name or anything in the person? We're going to look at that in just a second. Then we have a get and a set for the student number attribute. This is all that we have in a file called student.java. Okay. And the keyword here is, once more, the keyword here is extends. And extends say we would like to use the class, we would like to use the class person as a blueprint for the student class. Is everyone with me?
Certain. Why is super just hovering over there? Like, what does super have to? Oh, yeah, I see now. It's saying super.
Yeah. So super, we talk about a superclass and a subclass. Super meaning above, right? Sub meaning under or beneath. The constructor of the subclass, we can use super to call the constructor of the superclass. So the parent or the class we're inheriting from. Does that make sense?
I'm not sure, sir.
Okay.
Like, is it the same like the person and the student?
Yes.
Like superclass, the person, and the subclass is a student.
Yeah.
Like that?
So over here, this is the subclass, and this is the super class.
Yes, sir.
Okay. So when we call super, we are actually calling this method.
The big class.
Yeah. So this is from the context of the student class. This is our context.
Yeah.
However, it is important to note that we can only use super. We can only go if you had a whole bunch of classes in inheritance. So like one class and then another class that inherits all the way down. Super only goes this way. We can't go from this class and access anything in this class down here. Super and inheritance only goes back up the chain.
What do you mean, sir?
So let me just erase here. So in the person, we have access to everything that the person has access to, the name, the different methods. There is
Yes.
no way for us to access anything in the student class.
Yes.
It's illegal. However, from the student, we have access to everything in the student class, and then through super, we have access to things in the parent class. Does that make sense?
So how come student has access to the person?
That's because it is extending the person class.
Okay.
So it underneath, it's just a layer on top of the person. So if you think of the person class over here, right, with certain things, and then we extend, so we put the student class above with something, we can still access things in the person. We're composing a new class. Does it make sense?
Okay, so I think I was going to get it, sir.
Okay. It gets tricky, so please do ask questions if I'm not explaining it well enough. Okay. Okay. So inheritance is a kind of a one-way, like a waterfall, right? You can go from like the big general pool of everything you can access and then specialize down to things, but it's very difficult to go, or it's very difficult to access things downstream. Okay, so we'll talk about that a bit more. For now, we should just know that when we call super, we are actually calling the person constructor. Okay.
So,
Yes, go ahead.
so what if when we call super and we call the person constructor, what if we have multiple constructors in the person class? What would happen then?
So what you would then need to do is overload your student constructors, and you might have a student number and a name. And then you would call just like you would call a constructor for the parent, for the person, but you would say super and give it the name. You just pass the attribute along. Does that make sense?
Okay, so that makes sense.
Yeah. So this is how you would achieve that. So for task 2, in the assignment, should maybe take note of this. Okay. All right. I'll move on for now. We've only got a couple of slides left, and then we'll do some demos. So we use super to call the constructor of the superclass or the parent class. Okay. You can think of it like a family where you have a parent and it gives you a child, and then that child might have another child, right? And then this is a grandparent. This is a parent of this child, and so on. And this class, a parent might have many different children who also have other different classes that they create, right? So that's the idea, and then super just goes up one level from the child class. Okay.
So,
Go ahead.
regarding this example you just made, is super only able to go up one class?
Only
Can it
one
go
level.
up
Yeah.
Okay.
Super only goes up one level.
Okay, so
Yeah.
thank you.
All right. So if we have a demo file, we can create a student We can set the name, so we can call methods that are in the parent class. And we can set the student number, and then we can say hello. This is because the student has inherited all of the methods and attributes present in the person class. Okay, so I'm going to jump to a demo now to make this a bit clearer, hopefully, and we can do that. There's also a to-do. These are just exercises to get you thinking about how to write classes. But I think if you're busy with the assignment, then you don't have to worry about these so much. But yeah, and then there's some further reading. So you can look at the Wikibooks link. This is for how the compiling process works. It's not just for object-oriented programming, it's for Java in general. And then this over here talks about how the compiler looks for classes. Okay, so these are two useful articles. They're not mandatory reading, but they'll help you with your understanding. Okay, so with all of that out the way, let's do some demos. So over here, we have a couple of classes. Let's have a look. So I'm going to remove the class files. And we have a person.java, a student demo, and a student.java. So if we open up the person.java, the student, we have the following. So we've got a private string name. We have a constructor for a person, this.name. We have a get, a set, just like we saw. If we open up the student, whoops, it's my fault. We open up the student.java. We'll see that the class student extends person. We have a private student number. We have a constructor that calls super. We have a getter and a setter. Okay, we do not have the say hello, as is seen over here, because we're inheriting that method. Okay, so let's finally look at the student.java, studentdemo.java. And here we just have a student named Jack with a student number 12345, and they say hello. Okay, so just to recap, if we now call student demo, so let's look. Let's look here. There are no class files present. If I compile the studentdemo.java, how many class files do you think I will get? And which ones? Let me actually just check the chat so we don't miss anything.
So once you get 2 from student and person.
Student and person and student demo. But you're correct in assuming that we will get both the student and the person. Because what the compiler is doing is it will start with the student demo and start compiling, and then see it's using the student class. It will find the student class, compile that, and see that the student class extends the person class. And then it will compile that as well. So it's going to chain in, it's going to link and chain all the different classes we use. So if we then compile the student demo, oh, I made a mistake. It's Java line 11. We can close these. If we go, sorry, yeah. We have that, and if we try to recompile. Okay, so now we've compiled, and just like you guessed, well, you probably didn't guess, you knew, we have 3 different classes, one for each class that is being used. We don't have class files for hello or main, because these are not being used anywhere in the program that we compiled. Everyone understand?
Yes, so.
Okay, excellent. So if we then run this, we run student demo. Hi, my name is Jack.
So turn it into a class.
Say again. Sorry, say again.
was that class, the person class and student class always there, or did it come into after you ran the program?
No, so when we compiled it, it created the .class files. So it compiled every file that is related to the program that we're running. So we wrote person.java, we wrote student.java.
Okay, sir.
Yeah. All right, so now, because we've compiled all the other classes, if we try to run person, we say there's no main method, and if we try to run student, it says there's no main method. Okay, so even though they're compiled, we can't run them. We can only run the student demo, which has the entry point. And I think if we do this, okay. Anyway, I just want to have a look here quick. So if you're interested, you can always look at, you can always use Java P to actually decompile a program and look at what everything is. So we could go Java P, and I think it's this person. Do this. So if we decompile the student demo.java, you'll see all the Java bytecode that's being created. So this is all the stuff here. You can see that the class file has a checksum compiled from the source file name. You have a line public class, a versioning information. This class, superclass, is a, so you can look here, the student demo has a superclass, Java Lang object. It has 0 interfaces, 0 fields, 2 methods, and 1 attribute. There's a method reference for the creation, initialization of a student class. It has a method reference for student creation. It has a constant for a string, and it has another method reference for this. So these are all the different things that it can do. It also has a bunch of things, and then you can look at the actual file. So this is bytecode that it's reading through. This is your entry point, where it's got some flags, and then here it's doing all the different things. So you can see it's commented the code in for us. So if you've ever wondered what the Java bytecode looks like, it looks a little something like this. Okay. If we then go to the student, if we open up the student for reading, you will see here that we have a class file, student.class, in our little path. You can see it is compiled from the student.java. It also has a superclass called person. Okay, so that is, when we say super, this is what we're referring to. When we say this is what we're referring to. Okay, it also lists the static references. So there's a constant, none, which is this constant over here. There is a student number, which is a reference to a field, and that's this field over here. And you can see that we have one field, and that's student number. We have 3 methods, the constructor, getStudent, and setStudent, and we have 1 attribute. Okay. Then you can see we have 2 classes that we're referring to, a field, which is a string, right? These are all just the strings. And then down here, you can see that we have a string called none, and this is all the bytecode of the class. This is all the bytecode for that method, and so on and so forth. So it's actually, you can decompile your class files to make them a bit more readable. Okay. But I don't want to get distracted because we only have a couple of minutes left. I do want to show you something that works with inheritance that you need to understand now. Let me just have a look here. It's this. So let's just do this. So in our student demo, we have me.setName, set student number, say hello. Our student number is set to private. Where's our student class? Our student number is set to private. So what happens if we try to say we try to access it directly? Anyone want to guess?
Won't it give an error, sir?
Exactly. So it's going to give an error where student number has private access in student. However, if we went back to the student class and what do you think will happen if in the constructor we try to access the name variable? So let's just say something like that. So the name variable.
Wouldn't it work if you put private in front of the thing you were typing previously?
No. So private describes access. It's an attribute. It's not a keyword in that it can make something not private or let you access something private. It tells the compiler that the student number should only be accessible inside the student class. Okay. So with the person, we have a private string name, but now in the student class, we are saying this.name. What do you think will happen?
So could you repeat that?
Yeah.
So won't it stop an error, sir, because it's private?
Yes. So let's have a look.
So won't it stop an error, sir, because it's private?
Yes. So let's have a look. All right. So we have a private attribute name in the person, and then if we try to access it within the student, we'll have a look and see what happens. So it is private because student, even though it extends the person, is not allowed to access anything that is private inside of the person class. Okay, so that's a big thing to understand. Next lecture, we're going to look at something called protected, or I think maybe on Thursday, we'll look at something called protected, which lets you access things from derived classes. All right, we have about 5 minutes. Are there any questions so far? We'll recap all of this on Wednesday's lecture.
So I have one more question about the super keyword.
Go ahead.
Okay, when you use super in the construction of the student class, for example, in your program, how would you access the attributes that the student inherits? Would you need to, if you don't have a getter and setter method, would you need to use the person class or the student class to access those attributes?
Would you be able to do something like this? This.getName. Let's see if that will work. Because getName is a public method.
Yes.
So it does work. So we can call this.getName from the student, and it will go, it will go to the person class and access the name. So what's happening here is this is encapsulation in practice. Encapsulation, information hiding, whatever you want to call it. We control strictly how the name is being transferred. If you recall, the reason why we would do something like this, if you recall, arrays are addresses in memory. And if you just return the array address, the person will have direct access to the array's spot in memory. So instead, when we get an array from a class, we want to copy and create a new version of that class a new version of that array that's not linked to the object's data. Does that make sense?
Okay.
Yeah.
Yeah, it makes sense, sir.
Any final questions before we close off for today? I know it's quite a lot, so we'll do question and answers before Wednesday's lecture as well.
So far, I think I'm fine for now, sir.
Okay.
Thank you.
Excellent. Well, if there are no further questions, have an excellent afternoon, and I will see you on Wednesday for another lecture.
Yes, sir. Thank you. Enjoy your day, sir.
You
Don't forget
too.
to drink water.
Thank you very much.